Welcome back. In this video, we are going to solve problem 5.9 that is taken from chapter number 5, Analysis and Design of Beam, and the book name is Mechanics of Material by Beer and Johnston, 6th edition. So statement is draw the shear and bending moment diagrams for the beam and loading shown and determine the maximum absolute value of shear and bending moment. So let's start with the solution. You can see that there is overhanging beam AB having pin support at point A and roller support at point C. From A to C, we have a distributed load, uniformly distributed load of 12 kilonewton per meter, and at point B, we have a point load. So we will solve this question by using two methods. First method will be, I will now define first method is by finding shear and bending moment equations, and then we will solve the second method later on. Okay, so for that what I have to do is that if you remove this pin support at point A, so you will be having a reaction force. Let this is represented as A, and if you remove this roller support at point C, so you will be having a vertical reaction which is C, and we will find this A and C in the first step. And you can see that there is a uniformly distributed load of 12 kilonewton, and this uniformly distributed load when converted into a point load, so it will be 12 multiplied by the length over which it acts, so it is 2, so 24 kilonewton point load is acting, and that will be act at the middle of this AC. So this distance will be 1 meter, and this will be also 1 meter distance. Okay, now we will find this A and C by using equation of equilibrium. So first equation of equilibrium is that sum of all moment about point C is equal to 0, and taking the counterclockwise moment as positive. So you can see about point C, the first moment is due to this A load, and the perpendicular distance is 2, and this is producing clockwise movement, so it will be negative. So I can write A minus A time A multiplied by 2. The second load that is producing movement about point C is this 24 kilonewton, and perpendicular distance is 1, and this is producing counterclockwise movement, so it will be positive. So I will write 24 multiplied by 1. And the third moment that is produced by this 40 kilonewton load, and perpendicular distance is 1, and this is clockwise, so it will be negative. So I can write it minus 40 times 1 is equal to 0. So it means that 2A will be equal to 24 minus 24 plus 40. Sorry, let me do it by step, minus 2A plus 24 minus 40 is equal to 0. So 2A is equal to minus 16. So from here you can see that A will be equal to minus 8 kilonewton. Now our answer is negative, so it means that our assumed direction of A is wrong, and it should be opposite to assumed direction. So what I will write is that A will be equal to 8 kilonewton, and the direction will be downward. Now we have this A, so we'll find this Cy by using another equation of equilibrium, that is sum of all forces along y direction must be equal to 0, and upward force is taken as positive. So you can see A, which is downward, so minus 8 kilonewton minus this 24 kilonewton load plus C minus 40 is equal to 0. So from here you will get C will be equal to, let me calculate it, minus 8 minus 24 minus 40, and that will give you minus 72. So C is equal to 72 kilo Newton. So it is positive, so it means that our assumed direction that C is taken upward is correct. Now you have both A and C. So what we will do is that we will move to find the shear force equation and bending moment equation. You can see there is a load for region AC having distributed load, and then from C to B there is a point load. So what we will do is that we will take two regions. So first I will take region AC. So for region AC, and AC, for that x will be greater than or equal to 0 and less than or equal to 2 meter. So what I will do is that I will cut this beam in region AC and take this distance x, and we will draw the free body diagram over here. So let me draw it first. So this is the beam, this is your point A where you have downward load which is 8 kilonewton, and this total length of this beam where we have cut this, it is x, and on that we have a uniformly distributed load that is downward, and the magnitude of that uniformly distributed load is 12 kilonewton per meter. And when you cut it at this is your point A. So when you cut it, so you will be having a shear force which will be downward, clear, and that will be equal to V, and you will be having a moment M. Let this point is taken as J. So we will find this M and V by using equilibrium equation. So first equation is that sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So 8 kilonewton which is downward, so minus 8, and this distributed load when converted into a point load, so it will be equal to 12 times the distance over which it acts, and that is x, and it will act at x by 2 from either side. So x by 2 from either side. Okay, so minus 8, minus 12, and minus V is equal to 0. So from here you will get V will be equal to minus this 12x, minus 8 minus 12 times x, and unit will be kilo Newton. Let this is your equation number 1, and this equation 1 is valid shear force equation for region AC. Now we'll find this moment by using equation that sum of all moment about point J is equal to 0 and taking the counterclockwise moment as positive. So about point J, the first moment is this external moment which is clockwise, so minus M, counterclockwise, so it will be plus M. The second load which is producing moment about point J is 12x, and perpendicular distance is x by 2, and this is also producing counterclockwise movement, so it will be positive. So I will write plus 12x into x by 2. And the last load which is producing movement about point J is 8 kilonewton, and perpendicular distance is x, and also producing counterclockwise movement, so it will be positive. So I will write plus 8 into x is equal to 0. So if you simplify it, so m plus 6x square plus 8x is equal to 0. So from here you will get this moment is equal to minus 6x square minus 8x, and unit will be into kilonewton into meter, and this is your equation number 2. Now equation 1 and 2 are shear force and bending moment equation. They are valid for shear force and bending moment diagram. If you want to find the shear force and bending moment diagram in region AC, so you can use these two equations. Now what we will do is that we will find for another region, that is region CB. So you can see this is the region CB. So what we will do is that for region CB, what I will do is that I will cut the beam somewhere here, and you can see this will be X. Clear? Now you have one portion, this one, and on another one is on right side. So we will take the right hand side. You can also take the left, but you can see that right hand side is simple to draw. So I will draw the right hand side. So the free body diagram will be like this. This is your points B, where you have 40 kilonewton load, 40 kilonewton load, and this is your point where you have cut it. So when you cut it, so you will have shear force and you will be having a moment M, and let this is your point K. Now what is this distance? So let me show you that this distance will be equal to 3 minus x. Why? Because you can see the total length is 3 meter, this is 3, and this is x. Clear? Where you have section 8. So this distance will be 3 minus x. Okay, so this is 3 minus x. Now we'll find this V and M by using equation of equilibrium, and here x will be greater than 2 meter and less or equal to 3 meter. Okay, so we'll find this V and M by using equation of equilibrium. So first equation of equilibrium is that sum of all forces along y direction must be equal to 0 and upward force is taken as positive. So V is upward minus this 40 kilonewton is downward. Their sum must be equal to 0. So it means that V is equal to 40 kilonewton. This is your equation number 3, and this is the shear force equation for region BC. BC. Yes, BC. Now we'll find this M by using equation sum of all moment about point K is equal to 0 and taking the counterclockwise moment as positive. So you can see this reaction moment, which is clockwise, minus 40 into 40 kilonewton load into perpendicular distance 3 minus x is producing clockwise. So their sum must be equal to 0. So I will write it over here as that M will be equal to minus 120 plus 40x, and unit will be Newton into meter, and this is your equation number 4. Now this equation 3 and 4 are valid for shear force and bending moment. I will write shortcut bending moment for region BC. Okay. Now with the help of this equation 1, 2, 3, 4, I will draw the shear force and bending moment diagram. So what we will do is that I will take the vertical line from the end of this beam. Let me take it. This is the end lines of this beam, and first we will draw the shear force diagram. So for shear force diagram, I will draw horizontal line that represent x, and x is in meter. On y-axis you have shear force having unit kilonewton. Let each division is of 10. So 10 kilonewton, 20, 30, and this is your 40. Same is minus 10, minus 20, minus 30, and so on. Okay, starting for region AC. So this is for region AC. This is your C point and this is your A point. Okay, starting at point A. So you can see if you put x is equal to 0 in this equation. So where I have to write, okay, so focus on this equation. I will write it over here for x is equal to 0 in equation 1. That will give you, this will be 0. So it will give you V is equal to minus 8. V is equal to minus 8 kilonewton. Now for x is equal to how much? That we are going to find at 2. So at x is equal to 2 in equation number 2. So you can see that 12 into 2 is minus 24 and minus 8 is minus 36. So, 12 into 4 to 2 is minus 24 and minus 8 is minus 32. So V is equal to minus 32 kilonewton. So what we will do is that we will plot these 2 points. So at point A we have minus x is equal to 0 minus 8. So let's say minus 8 is here. Also you can see at A we have 8 kilonewton downwards. So this is minus 8. Now what about point C? At point C we have minus 32. So minus 32 will be somewhere here. This is minus 32. Now you can see that if you want to plot the different value for different value of x, you can just plug in the value in this x, so you will get different points like this. But there is a short method that you can see that uniformly distributed load is a horizontal line with 0 degree and that is downward. So bending shear force will be 1 degree higher and it will be a straight line and slope will be decreasing. So you can just directly join these 2 points. Okay, now this is for region, this is CB. Now for region CB, this was for region AC. Now for region AC, you can see that V is already calculated, which is just 40 kilonewton, constant number without X. So V is 40 kilonewton. Okay, so at X is equal to 2, greater or equal to 2 and less than 3. So here also you can see that C is acting downward. So which will see the value of C is 72, 72. So minus 32 plus 72 will give you plus 40. And also you can see you are getting plus 40. So shear force will change from this to plus 40. This is plus 40. And then we will move upward. Now for region CB, this 40 kilonewton is constant and you can see there is no load between C and B, so it will remain constant. And at point B, you can see you have minus 40 kilonewton load, which will cause it to bring it to 0. So this is your shear force diagram. Now we will draw the bending moment diagram. So for bending moment diagram, what I have to do is that I have to take a horizontal line, and again x shows in meter, and on y-axis you have moment having unit kilonewton into meter. Okay, what we will do is that we will take each division as minus 10. So below it is minus 10, minus 20, minus 30, minus 40. Okay, now what we will do is that we will use equation 2. So put for region AC, put x is equal to 0 in equation number 2. This is your equation number 2. So you can see both are the function of x. So if you put x is equal to 0, so moment will be equal to 0. Now put x is equal to 2 in equation number 2. You can also put different value of x such as 0.5, 1 and so on. But for direct method or for shortly to reduce time, we will put some values. So moment will be equal to, okay, just plug the value. So 8 2s are 16, so minus 16 and minus 6 times 2 2 4. So minus 24 and minus 16 will give you minus 40. Okay, so this is minus 40, m will be minus 40. So we'll just plot them. At x is equal to 0, we have this moment is equal to 0, and at x is equal to 4, this is minus 40. Now you can see that this shear force is a 1 degree line and slope is decreasing. So bending moment will be 1 degree higher, and it will be like curve, second degree curve with in clockwise direction. Okay. Now for region BC. So you can see the moment equation, put x is equal to how much? It is equal to 3. And again, if you can put the value of x is equal to 2, so you can see this is 40 into 2 is 80, minus 120 will give you minus 40, which is exactly the same at this point. So put x is equal to 3 now. So when you put x is equal to 3, so this will be 4 multiplied by 3 is plus 120, and this minus 120 will cancel each other. So we will get moment is equal to 0. So I will get m is equal to 0. It means that at x is equal to 3 meter, we have moment is equal to 0. And now you can see that shear force is a horizontal line with 0 degree. So bending moment will be 1 degree higher under this, and it will be a straight line, and slope will be increasing because area under the shear force diagram is positive area. So this is bending moment diagram. Now this was our first part. In second part, we have to find the maximum absolute value of shear and bending moment. So from shear force diagram, you can see the maximum value is 40, and for bending moment diagram, it is also 40. So what we will write is that in part B, maximum absolute value of shear stress is 40 kilonewton, and maximum absolute value of bending stress is minus 40 kilonewton, and we will take the mod because we need the maximum value. So it will be 40 kilonewton into meter, and which is the answer of our this question. Now we will solve this question by using direct method. So for that, I will take this figure and we will copy it and move toward the next page. Okay, so this is the next page. Okay, so we will use method number 2, which is the direct method. I will show you how you will quickly solve this equation by using direct method if you have clear understanding. So what will be the first step? The first step is that we will find this reaction force. Again, we have find out this. This was 2 kilonewton and this was 72 kilonewton. That is was C and that was A. You can, okay, this is 8, I think. 8 kilonewton. Let me check it. 8 kilonewton. Yes. And this is 72. After that, we will draw the shear force and bending moment diagram. So again, what we will do is that we will take the lines from end of the beam, clear, like this. Okay. Now first we will draw the shear force diagram. So for shear force diagram, I will take horizontal line to show x in meter. And here we have shear force in kilonewton. Okay, this is your point A, this is your point C, and this is your point B. Okay, at point A, you can see you have minus 8 kilonewton. Okay, what we will do is that we will take this as 10 kilonewton. So 10, 20, 30, and 40. Similarly, minus 10, minus 20, minus 30, and so on. So at first point, we have minus 8. So minus 8 is this point. Let this is minus 8, the dot one. So at this point, this is minus 8. Now at point C, when this distributed load is multiplied with 22, so it will give you minus 24 because it is downward. So 12 multiplied by 2 will give you minus 24, minus 12 because it is downward. Now what will be the total shear force at point C? That will be, you can see this is minus 8 is already there and minus 24, which will bring it to minus 32. So minus 24 and minus 8 is minus 32. So it will be somewhere here, minus 32. I will write it minus 8 is already there and minus 24 is equal to minus 32 at point C. Okay, and you can see that shear force, the distributed load is a straight line with 0 degree. So shear force will be 1 degree higher and it will be a straight line and slope will be decreasing. Now moving from C to B, there is no load. So it will remain horizontal at this point okay, one more thing is that here at point C, you have 72 kilonewton load. So now minus 32 plus 72 will give you plus 40 kilonewton load. So shear force will change from minus 32 to plus 40. So you have to be very careful. Now from C to B, there is no load, so it will remain horizontal. And at the end, you can see you have minus 40 kilonewton load, which is acting downward. So this will close this loop and we will get the shear force diagram. And you have seen that this is very easy method as compared to the previous one. Now second thing is that we have to find the bending moment, and again x is in meter. Here you have bending moment which having unit kilonewton into meter. Let each division is minus 10, 10. So below is minus 10, minus 20, minus 30 and minus 40. Now at x is equal to 0, the moment at point will be equal to 0. So I will get this point. Initial point is this one, which is 0. And the area, as we know that area under the shear force diagram will give you bending moment, and this is the area. And you can see this is trapezoid. I will write it, this trapezoid. Area under AC shear force diagram is trapezoid, and this area of trapezoid is equal to 1 over 2 A plus B into H, where A and B are parallel sides. So you can see these two are parallel sides. So minus 8 minus 32. So I will write 1 over 2 into minus 8 minus 32 multiply by height. So height is in between these two parallel line, and this height you can see this is 2 meter. So I will write it multiply by 2. So again minus 40 divided by 2 multiply by 2. So this area will be equal to minus 40. So the bending moment at point C will be minus 40. And again you can see that shear force is a 1 degree line and slope is decreasing. So bending moment will be second degree curve, and it will be like this. Okay. Now what we will do is that we will find the area under this shear force diagram for region CB. So this for CB, this area will be equal to this height 40 and length is 1. So 40 multiplied by 1 is plus 40. Okay, so minus 40 is already there. So minus 40 plus 40 will give you 0 at point B. So bending moment at point B will be 0. It will be like here. And the last thing is that shear force is a horizontal line. So bending moment will be 1 degree straight line. And since this area is positive, so its slope will be increasing. So this is your bending moment diagram. Now you can compare both this one and this previous one. Both are same. So the second part was again maximum shear force mod and maximum bending moment. So from here you can see the maximum shear force is plus 40 kilonewton and maximum absolute value is minus 40 kilonewton. So we need the maximum absolute value that will be equal to plus 40 kilonewton into meter. And that is again answers are same. So this is the another method. I hope the second method is easier than the first one, but I want to have both the methods so that you can easily solve by any method based or availability of time in your exam. So this was all about this problem 5.9. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching.